What if Earth's oceans evaporated? If Earth's oceans evaporated, our planet would be transformed in ways both profound and catastrophic, reshaping the environment, life, and even the Earth itself in ways almost unimaginable. To grasp the transformative power of the oceans disappearing, let's journey across the global changes, physical, chemical, biological, and even cultural, that would follow the evaporation of the seas. Before anything else, let's imagine the starting conditions. For any scenario that could cause Earth's oceans to evaporate, fundamental and devastating changes would already be afoot. Perhaps the sun has grown hotter, or greenhouse effects have spiraled out of control. However it happens, Earth's roughly 1.35 billion cubic kilometers of water, spread across 5 great oceans and countless seas, rivers, and lakes, begins to transition from liquid to vapor, a planet-wide event. From the first moment, Earth would begin to look very different. The endless blue expanse that covers over 70% of the planet's surface would vanish, replaced by vast, gleaming salt flats, exposed ocean basins, and gaping underwater ridges and trenches usually hidden beneath kilometers of water. Large tracts of the planet would resemble the moonscape of the Dead Sea or California's dry lake beds, only on an unimaginably larger scale. But it is not only the aesthetics of Earth that change. The oceans act as our planet's thermostat and engine, regulating temperatures, weather, and much of the planet's life cycles. Their evaporation would send shockwaves through every system, each domino toppling onto the next. As the first waves of evaporation take hold, the moisture in the atmosphere would skyrocket. The hydrological cycle, the movement of water through evaporation, condensation, and precipitation, would go into overdrive. Clouds would proliferate, at least in the early stages, and the sky could be choked with wind-blown vapor. Torrential rains might sweep the planet, only for those drops to be instantly reabsorbed. As the conditions that cause the oceans to evaporate would also make holding onto that water in liquid form impossible. As the atmosphere supersaturates, it would become stiflingly humid, with air containing far more water vapor than before. That vapor, in turn, is a powerful greenhouse gas, much more so than carbon dioxide. As the water vapor content of the atmosphere increases, so too does its ability to trap heat from the sun, leading to an extreme acceleration of global warming. Temperatures could rocket upwards, easily surpassing any current records. The heat would not be distributed evenly. Coasts and equatorial regions, hot and exposed, would dry and burn first. Higher latitudes in the deep ocean trenches might linger a little longer in cooler, wetter conditions, but nowhere on Earth would be safe. The transformation is all-encompassing. Atmospheric pressure would increase dramatically. As water vapor is lighter than air, the standard mixture of nitrogen and oxygen would be displaced, and the total mass of the atmosphere packed onto the planet would grow. The sky might fade from blue to a hazy gray, thick with humidity. Breathing would be difficult. The oxygen percentage would drop, as some would be replaced by heavier concentrations of vapor. Human beings and most land animals would find it increasingly hard to survive, even with artificial means. Eventually, the water vapor would reach a tipping point in the upper atmosphere. There, radiation from the sun would split the H2O molecules into hydrogen and oxygen. The lightweight hydrogen would quickly escape into space, never to return. In a process known as hydrodynamic escape, the loss of hydrogen would mean a permanent loss of water, echoing the fate of Venus, Earth's planetary neighbor, believed to have once had oceans of its own. Meanwhile, the planet below would be ravaged by heat. With no water to absorb the sun's energy, land temperatures would skyrocket. The absence of oceans would also mean no more moderation of the climate. There would be no more cool sea breezes, no heat storage in winter to keep polar areas warm, and no regulation of the planet's temperature through ocean currents, like the Gulf Stream. Extremes would dominate. Summers would become more blistering, winters even more biting in regions prone to cold, yet everywhere would trend toward a lifeless, parched norm. Weather patterns would be altered beyond recognition, and then, eventually, would collapse entirely. The great conveyor belts of ocean currents, such as the Atlantic meridional overturning circulation, would cease to function. The entire global water cycle would grind to a halt as liquid water became effectively extinct. The disappearance of the oceans would quickly mean the end of rain. Without seas to evaporate, and with what remaining lakes and rivers quickly sublimating or evaporating, precipitation would grind to a halt. The rich, forested areas of the world would wither, grasslands would brown and burn, and deserts would sprawl over previously lush lands. This would mean the collapse of nearly every terrestrial ecosystem. Life on land, dependent on fresh water from rainfall or aquifers, would wither and die. Deep-rooted plants, oaks, redwoods, even cacti, would succumb as their groundwater sources dried up. The last survivors, perhaps microbial life in deep-water oases or underground aquifers, would be doomed as the global water budget fell to zero. The collapse of the oceans would be even more devastating to ocean life. 99% of Earth's living space is in its oceans, which contain everything from microscopic plankton that form the foundation of the food chain, up through giant whales, coral reefs, and more than 1 million described species. As the seas evaporated, they would first concentrate into hypersaline brines. Salt content would skyrocket, devastating almost all multicellular ocean life. The last refugees might be hypersaline microbes, extremophiles that exist today in places like the Dead Sea and Great Salt Lake, yet even they would run out of water as evaporation finished its work. The coral reefs, the rainforests of the sea, would bleach, dry, and be exposed to unfiltered UV radiation, their delicate structures crumbling to dust. The tides themselves, driven by the gravitational grasp of the moon, would cease. With no oceans to pull, the tides would be little more than bulges in the crust of the earth, undetectable except to sensitive instruments. All the fisheries of the world, suppliers of food to billions, would go extinct. Whales, dolphins, fish, mollusks, and all the complex, beautiful web of ocean life would vanish with them. Even the shells of ancient sea creatures, normally buried by the sedimentation of the ocean floor, would be exposed to weathering and eroded by wind-blown sand and the fierce energy of solar radiation. And what of humanity? Modern civilization and all those before it have depended on the water cycle. Agriculture requires irrigation, cities require rivers, and societies themselves rise and fall according to their ability to manage water. Rivers that carved civilizations, the Nile, the Yangtze, the Ganges, would be reduced to memory. Drinking water would vanish. Reservoirs would dry, and dams would become hulking ruins in empty canyons. Retreating to the last vestiges, perhaps polar ice that hangs on for a little while, or protected subterranean aquifers, people might cling to existence, but as the skies deliver no new rain and the heat of vaporized water becomes overpowering, survival would dwindle to impossibility. Mass migrations would overwhelm the remaining habitable places, sparking conflict and desperation. Cities on the coasts, once centers of trade and culture, would become wastelands, abandoned to the expanding deserts. Inland, shifting winds and temperature extremes would make almost the entire planet inhospitable to life. Industry would collapse. Hydroelectric power, the lights of so many nations, would vanish. Power stations relying on water for cooling would overheat and shut down. Nuclear plants might fail as their coolant sources withered, risking disaster. The great ships that once crossed the seas would lie stranded on dry basins, rusting and battered by wind. Shipping, a backbone of the global economy for millennia, would die with the ocean. Air travel would be hampered by denser, moister, and more turbulent air, at least in the early stages. But as global temperatures soared, everything would grind to a halt. In the absence of the oceans, geological processes would be laid bare. Enormous trenches, like the Mariana, would gape open, stretching 11 kilometers deep, more than Mount Everest is tall. Long buried ridges, seamounts, and volcanic chains, once home to unique communities of life around hydrothermal vents, would bake in the sun. Ice remaining at the poles, if there were any left to linger, would quickly evaporate, as the conditions that boiled away the oceans would not spare glaciers or permafrost. Antarctica and Greenland would transform from vast frozen continents to salt-caked wastelands. Without the mass of the oceans pressing down on the crust, isostatic rebound, geological uplift, would begin. Land that has been suppressed by the weight of kilometers of water for millions of years would start to rise. Earthquakes would ripple through regions as the crust adjusted. Tsunamis would be a relic of the past, but the upheaval would give rise to massive landslides, rockfalls, and seismic chaos. The very shape of the continents would change as a result. The interiors of the former ocean basins might develop hyper-arid climates, with gigatons of formerly dissolved minerals crystallizing out as elaborate salt deposits. New mineral resources would be exposed, once only accessible via deep-sea mining. Meanwhile, volcanic activity could increase as the reduction of pressure from the lost water made it easier for magma to rise. The ring of fire would still flame, perhaps more vigorously now that its watery shroud was gone. With the passing of the ocean comes another loss, one of cultural significance. Myths, stories, art, and history are deeply intertwined with the sea. For millennia, the oceans inspired explorers, traders, and dreamers, and shaped religion and philosophy. From Homer's Odyssey to the stories of Atlantis, from Polynesian wayfinders to modern oceanographers, the sea compelled us to search, fear, and learn. All gone, replaced by sun-blasted basins and endless shimmering wastelands of salt. It is not only the surface world that would be transformed. The Earth's chemistry itself would shift. Oceans are a vast reservoir of dissolved carbon dioxide, buffering the planet against swings in atmospheric CO2. With the oceans gone, all that CO2 would be released, both from evaporation and from the breakdown of marine carbonates exposed to air. The greenhouse effect would be further supercharged. And then there is the carbon cycle, so critical to stabilizing climate. With no plankton performing photosynthesis, and forests and grasslands dead, Earth would lose much of its ability to process and sequester carbon. Atmospheric CO2 would skyrocket, turning our planet into a greenhouse reminiscent of Venus. Losing the oceans also means Earth's magnetic field and tectonic activity would be unbalanced. The movement of salty seawater helps drive the geodynamo effect that maintains Earth's magnetic field. With dry ocean basins, that contribution fades, and perhaps over long stretches of time, Earth's protective magnetic bubble could weaken, leaving the surface even more vulnerable to solar and cosmic radiation. On a longer timeline, the loss of water vapor means no more weathering of rocks that helps regulate atmospheric CO2. Earth would turn into a hothouse, unable to cool itself, as wind-driven dust storms replaced rainfall. Life, as it always does, might attempt to adapt. Microbes deep underground, shielded from heat and desiccation, could survive in pockets for a while. Certain extremophiles, those already living in tiny, salty, boiling pools, might linger on the fringes, in caves, or in cracks deep enough to shield them from the worst of the surface apocalypse. But in time, without a renewing, circulating water cycle, these too would die off. Earth could become a near-sterile world. Geologically, after the ocean's evaporation, a planet-sized salt crust would form on the ancient seafloors. Great flats of sodium chloride, magnesium sulfate, calcium carbonate, and other minerals would form bright, reflective surfaces, beacons visible from space. This reflective crust could in some ways slow further heating by bouncing more sunlight back into space, but by then, the catastrophic feedbacks would have already taken their toll. Oceans play another, more subtle role, the lubricating of tectonic plates. With no water present to seep into faults and lower melting points, earthquakes might change in character, perhaps becoming less frequent but more severe, or causing unusual faulting patterns. Far into the future, dust storms would become Earth's hallmark. Winds would scythe across the now flat plains where underwater mountains once stood. With nothing to bind soil and sand, these hypercanes could reach around the world, much like on Mars, stripping away whatever topsoil remained, polishing bedrock, and creating immense dunes and stone deserts. If any moons or asteroids looked down, Earth would appear changed, a dried-out ochre world, dazzled by vast salt sheets instead of blue. Over centuries and millennia, the chemistry and geology of Earth would approach a new equilibrium, though one utterly hostile to life as previously known. The majority of those changes, though, would be measured against the scale of humanity, our standards for comfort, survival, and beauty. Yet on universal scales, Earth would not be unique in having lost its water. 4 billion years ago, Venus may have had oceans as deep as Earth's and is now a superheated world with atmospheric pressures over 90 times those on Earth and lead melting surface temperatures. Mars, too, bears signs of ancient rivers, deltas, and perhaps even brief oceans, now replaced by a frozen, barren expanse. Earth, without its oceans, would become a warning, even more visible than Venus's fate. It would remind any future explorers, robotic or otherwise, of the fragility of the balance that makes a world habitable. And so, from the smallest bacterium to the arc of human civilization, every story on Earth is intertwined with its water. The evaporation of the oceans would be the end of our planet as we know it, not just in terms of its landscapes or its weather, but as the cradle of life. The blue planet would become a memory, its history etched in the salt flats and the silent deserted basins where once whales glided and continents met swollen surf. There would be a final silence, broken only by howling winds and the shifting baking crust, as if the Earth itself mourned the loss. Yet at the core of understanding such a scenario is the appreciation for how precious, yet fragile, our planetary water is. Oceans govern climate, create and sustain life, shape continents and societies, and make Earth unique among the known worlds. The thought experiment of their evaporation, as terrifying and desolate as it might be, serves as a stark reminder to treasure, protect, and understand the oceans, while they are still ours to marvel at and to care for. In reflecting on this, one might realize that the boundaries of possibility, of scientific imagination, are broad, and that the future of planet Earth, and all who sail upon her, relies on choices made today and understandings forged in appreciation of the irreplaceable blue world we call home. So next time you stand at the shore, watching the endless horizon and feeling the salt air on your skin, remember, the ocean is more than water. It is the beating heart of a living planet. If it were ever to vanish, every echo of life, everything we know, would fade into the desolation of dust and memory. That, perhaps, is the greatest lesson of all.